Okay, we are looking at, this is problem 11 from the absolute value lesson 1-1. We're given this function a of x is equal to negative 5 times the absolute value of x. And we're asked to do these things. Graph it, compare it to the parent, and describe the domain and range. So before we even get to graphing it, since it says compare to the parent, I think it's pretty clear that we talk about what the parent function looks like. So the parent function for absolute value looks like this. So this is f of x equals the absolute value of x. And this is the parent function. So what happens on the parent function is we have the vertex right here at the origin, and then it's growing forever to the right, forever to the left, it's going up, and the slope on the right is basically 1, right? We go up 1, right 1, or we can go up 2, right 2. But there's no stretch, shrink, or reflection. It's kind of right there. It's the basic function right there with the easy slope on the right, slope of 1, vertex right at the center. Now, as we start to add these other numbers around the parent function, we can actually do a whole bunch of things. Like we can get y equals a times x minus h plus k. So we can have a multiplier on the outside that will change the shape. We can add or subtract inside the absolute values, which will shift left or right. Or we can add or subtract at the end, which will pick the whole thing up. Okay, so this guy, this has got a multiplier out front and it's negative. So this is our a value, not to be confused with this a, this is the name of the function a, but this is the multiplier in front of the function. And that a value, oops, I wrote 5, that's wrong. It's negative 5. So this means because it's negative, it's upside down. And because it's negative 5, it's growing 5 times faster. Growing 5 times faster, which will mean it's going to look a lot narrower. It's going to look like it's been pulled apart this way. So if I was to do a sketch of this, let me zoom out a little bit so you can see a little bit more room. If I was to set up an x and y axis, right? X axis, y axis. That looks like another x. And I put this, here, I'll just write it here, a of x equals negative 5 times the absolute value of x. What I would do is I know it's flipped upside down and it hasn't been shifted left or right, up or down. So my vertex is still here, but now it's going down instead of up. And it's going down with a growth rate of negative 5. Down 1, 2, 3, 4, 5, and over 1. So the right side is actually going like this. And then the left side is the reflection of that. So it's going to the left and down 1. Oh, I did that in a Sharpie now. It looks weird. I'll Sharpie this side too. Okay, so it is significantly narrower. It has been pulled out this way. It's growing by a factor of 5 and it's upside down. And that's what they mean by compare to the parent function, because right, the parent function will be up here, kind of a more wider graph. It's like at a 45-degree angle. It's going up 1, right 1, up 2, left 2. On the left side, it's going up, up and left. So there's my parent function. Here's my function I just did here in Sharpie. So the comparison is, it is upside down, or I kind of already have it. It's reflected, maybe we'll say this way. It's reflected, if you want to be fancy, across the x-axis. That's a fancy way to say it's upside down. It's been reflected down here. And it is growing 5 times faster. So it has a vertical stretch by a factor of 5. Okay, so that's the comparison. We graphed it, and I was okay with you guys throwing this into Desmos to take a look at it. I graphed it here by hand because I've done a lot of practice with these and I know what they look like. But eventually you want to get to the point where you see that negative 5 and you do the same thing that I did. You know what the parent function looks like, and you know that negative 5 is putting it upside down and making the slope on the right be negative 5, down 5, right 1. We compared it to the parent function. It's reflected across the x-axis, growing 5 times faster, vertical stretch by a factor of 5. And the last thing we need to do is the domain and range. So I'm going to move it up so we can see it. Okay, your domain, as is for practically all absolute value functions, x is all real numbers. there is no x value we can't substitute into that equation. And we can see visually that although it's kind of narrow, it's still going to grow forever left and right. Our range is where it gets kind of interesting. It's not everything now. The range, if we look at it in terms of the y-axis, right, it's only covering the bottom of the y-axis. So your range is that y is all real numbers less than or equal to 0. It's everything under the x-axis, or under the x-axis. It's all negative values of y and 0, less than or equal to 0. Okay, hope that helps. Message me with questions.